Hello, welcome to the Virtual History of Science Museum. Wherever you are, Zilka Ackerman, I'm the director of the History of Science Museum, and it is a great pleasure of have you with us tonight. The event, or this morning, or lunchtime, wherever you may be. The event today is part of our Knowledge in Motion, Science and Medicine in the Islamic World series, which accompanies our wonderful new exhibition, Precious and Rare, Islamic Metalwork from the Courtauld, Cultures in Conversation. And you can see in the chat that details are coming up. Please join us virtually for the exhibition, or if you happen to be in the area, do pop in. We'd love to see you. Now, I'm delighted that we have with us today Dr. Taha Yasin Arslan. Taha is currently assistant professor at the Department of History of Science at the Istanbul Medeniyet University. His research focuses mainly on astronomical instruments and treatises and the use and construction of these instruments in the Islamic world. And as part of this research, he himself reconstructs these instruments, and you will see when he comes on screen that he has a few of them with him. We had hoped, of course, if this had been a physical event, to handle them, but this will not now be possible, so we will look at them virtually. Questions and answers can be put in the chat, and we would be delighted if you do so. We will try to answer as many questions as possible. If you would kindly mark your question as a question, which you can do when you click on the circle in the chat function, it comes up as a question, and then it will be easier for us to spot. But for now, over to you, Taha.
Thank you, Zilke. And hello, everyone. Thank you for joining us. And I would like to especially thank the History of Science Museum for hosting this wonderful lecture series for me, and to be able to share this information and whatever we can. It would be wonderful, and hopefully it'll be fruitful for you too. And let's get started. When I'm studying history of science, I usually try to find the roots of the scientific development, and I try to go as back as possible to understand and to make connections with the historical perspective. So I would like to take you back a little bit more than Islamic world, from the medieval period to very early ages, even before the invention of writing. And what we see that time and what we see today doesn't change much. And when you see a development in scientific understanding or astronomical ideas, you see many factors you can actually have to factor in. And two major factors we have to talk about is curiosity and necessity. And it always starts with curiosity in the history, I think, and because you have to consider how they were understanding things before instrumentation, before there is no parameter, or before there's no time zones or watches or anything. They were looking at sky and try to make sense of it. There's a light show, as you see on the picture. It's a beautiful light show, a wonderful sky. But more they experience, more they look at the sky, they started to see repetitions. And this repetition may have been random, but throughout their experiences, they started to understand it may not be too random. So that means if it's not too random, that you can make calculations to be able to periodize and try to make calendars to work with. And of course, there is a problem with this. You need to start with some fixed point to make your calculations, make your measurements. And because of this, we see these thousands of year old instruments. I would call them instruments because they are large buildings, but at the same time, their main function, perhaps one of the main functions, is to determine the time and fix the position of starting point of the calendars they were using. You see over there, of course, Stonehenge and one of the ziggurats from Mesopotamia. And what they would find here with the calendars, they started to past curiosity now, because they now use this calendars to be able to make their lives easier, because there are so many problems they're facing, and periodization of time using calendars might helpful. It was very helpful actually, and they use this, becoming the scientific development influenced by necessities now, and they were trying to solve their problems with calendars, and it worked for Babylonians, it worked partially perhaps, but still for the Egyptian people, and you start seeing this is the beginning, but at the same time necessity overthrow the curiosity until Greeks, because in the Greeks, in the ancient Greek, we start seeing they live in already established society. They have no problems of that they need to fix on. They use the same calendars, even a little bit with some small adjustments perhaps, but at the same time the necessities change, and their necessities are actually becoming more like curiosity, because they were trying to understand what is beyond what they can see. How can we comprehend what we could see that as a system and how it works? They needed to understand this, and they start asking questions Babylonians or Egyptians did not ask perhaps too loudly, and they try to make sense of the cosmological idea. And for this, they started to use instruments as well, as you see over there with the parallactic ruler, based on the descriptions of Ptolemy in the second century AD. And what they come up with is a spherical universe, and at the center of it, a spherical Earth standing still, and everything revolves around the Earth. And everyone else had to come up with ideas to explain this geometrically, mathematically, cosmologically, for nearly 2,000 years. But here curiosity takes over, as I said. We need much more balanced situation with curiosity and necessity in order to continue developments of the scientific ideas, specifically the instruments. And we come up with, we have to come to Islamic world to be able to see and say that. In the Islamic world, Muslims in the 8th century and the beginning of the 9th century, they inherited a large land. As you can see on the map, they already had inheritance of Greeks, Indians, Persians, Caucasians, Armenians, Africans, Spanish, tribes, and every region, even Chinese and Central Asians. They had put them all in one pot, one cultural pot, and this created a new understanding of how you can perceive the world as a Muslim, and at the same time they actually come up with new problems. So these problems had two sides again, with curiosity and necessity, and the necessities comes from inner problems, like Muslims trying to solve their own problems when they actually leave their Arabian Peninsula to becoming a larger land, and creating new problems and trying to solve the new problems they had to. And with this necessities comes a knowledge of timekeeping. And in the 8th century, in the late 8th century, but more the beginning of the 9th century, they started to solve the problems of like determining the prayer times, or calculating the beginning of the fasting month Ramadan, or any other problem they come up with, because when they are pilgrimage, they need to pray towards the direction of Mecca, and they have to solve the problem of Qibla, the direction of Mecca. And these problems are quite necessary, maybe not necessarily solved by mathematics, but the moment they receive the reception, they have the reception of mathematical sciences, they started to understand that they can use mathematics to solve these problems. And on the other hand, they were living very close to Christians, Jews, and the other religious and cultural population. So they started to encounter problems they never had to ask before. And they started to understand that, all right, yes, we know God created, so we believe that, but how? They never had to ask in the level of understanding that Christians were asking for a couple hundred years. So they had to come up with new answers. And this made them curious as well. Then that curiosity and necessity started to become in a balanced form to create another kind of emergence of branches of science, the theoretical astronomy and knowledge of preparing astronomical tables. When I say astronomical tables, I mean graphics or tables explaining with numerical data, which gives you the positions of the celestial objects, so you can read them as a mathematician or astronomer. So, and you can start visualize the rotation of those celestial objects to come up with some cosmological understanding or a theoretical astronomical understanding of those. And the main point we're trying to come here is instrumentation. And whatever you work on, which branch of astronomy you're working on, you need instruments. Because to be able to make a precise measurement, to be able to calculate things, you have to work on instrumentation, and you have to get better at instruments that you are using. This will happen in a large period of time, of course, but still you need those instruments. Throughout the Islamic world, let's say from 9th century to the 19th century, but we can actually end up in the 16th century because of the stretch is enough to be able to explain. From 9th to 16th century, we have 4 types of instrumentation. And there are some instruments that may not be under those categories, of course, but quite rare. So I would like to try to explain each category a little bit in detail what we see as instruments of observations only is very hard to come by, because in the Islamic world, they usually used only in observatories. And the idea is you observe with a very large instrument, and then what you come up with the numerical value, you use other instruments or you use your own calculations to continue your work and creating astronomical tables or making assumptions for theoretical astronomy. But the larger the instrument is and firm the instrument is, you can actually come up with much precise calculations. And they realized over time that you can do this, and you can calculate to very precise measurements like 1/10 of a second. As you see on the example, 1/3 of the remnants of the Samarkand Observatory sextant, from the 15th century. And this was in 40 meters in radius, and you could come up with extraordinarily precision calculations. And the problem is, when we track them, it's very hard to come by with this, because they're only used for observatories, yes, but when observatory finished its work, you don't need these instruments anymore. You can't carry them around, and you can't actually continue your observations, because once you have enough, let's say 40 years of numerical data, it will be helpful to you more than 200 years. So you don't actually have to go back to those kind of large instruments. So you need portable instruments to be able to work with in your daily lives. And well, there are exceptions to that, of course, but when you see the evolving instrumentation, you see in this kind of instruments, the evolution is only come by with becoming larger to be more precise. And one of the largest armillary spheres ever made is what you see in the image here on the left. Would be from Taqiyuddin ibn Rasid ibn Ma'ruf, known as Taqiyuddin al-Rasid, in Istanbul Observatory in the late 16th century. And it was one of the most magnificent models. But again, it was only used for 4 to 6 years during the observatory's active years, and then they just probably destroyed it, and it didn't actually arrive. It survived today. What comparing to the other, let's say, the instruments of observations, there are one particularly different kind of instrument, which is sundials. And sundials, although it can be used in observatories, you can also use it for different places. and even in palaces, in mosques, and muwakkits, the timekeepers, use them all the time in the mosques, so they can determine the time for and tell the muezzin, the perfect person who is responsible to perform the call to prayer, to say that it is time now, you can call to pray, perform the call to prayer perhaps. And this is, I think, the only, as far as I can actually come up with, this is the only popular instrument, only observational. So we have come less popular instruments with the instruments for computations or calculations, and these are more problematic, because once you have an observation instrument and a computational instrument, they usually prefer to use them together. So coming up with a new but only for computations instrument is quite rare. In fact, it's so rare, I have never seen a single extant version. On the left, you see my replica, and on the right, you see a 13th century treatise explaining a different kind of trigonometrical grid. These are instruments to use only for calculations. And what you need numerical data from observations from some other instrument, then employ these instruments to be able to make better calculations with those instruments. And let's come to the third type of it, which is the most popular one in the Islamic world, with the instruments for both observations and computations. And these are, as you can see, on the left is astrolabe, on the bottom is celestial globes. What you can do with astrolabe is you can actually make observations. One of the problems I might actually hear from the experts, that when I put here celestial globes, normally celestial globes, how to use it for observations, but at the same time quite rare. And when you actually read the manuals explaining how to use a celestial globe, for example, they usually give you very small detail about how to observe things, but most of the explanation is to explain how to measure things, like how long is the daylight for the specific date or for specific latitude, when is sun is setting or rising, how long will it take that, and they will use that information for any kind of calculation they want to do regarding that. And this is, for the Islamic world, this is the most popular version of these kind of instruments, is a combination of sine quadrant and astrolabe quadrant. And one side on the left is sine quadrant, which you can use for trigonometrical calculations. On the right, you can use for observations and measurements of determining time, determining the prayer, the Qibla direction of the Mecca. And these two instruments are almost always made in one single instrument as two faces of one single instrument. And it is easier than using an astrolabe because it has no, it has no different and turning parts. So you can use it much easier, and the manuals to explain how to use it is much less complex than an astrolabe. So specifically in the people working on timekeeping, like muwakkits, the timekeepers deal with these kind of instruments, and they were using a lot. And today we have only more than 100 of the examples, but from my experience, from my readings, I can imagine that this is arguably the largest collection. It was the largest collection in the Islamic world as instrumentation. There are also very unusual and not so popular instruments that we can actually see. And this is an instrument made by 14th century astronomer Ibn Shatir. And he was trying to find a way to combine both sides of what you see here. He's trying to combine with both sides of this, and he came up with different kind of grid. And this can be used for both observations and calculations, but it was quite rare, and he called it the perfect quadrant. It is perfect quadrant, yes, but it wasn't popular, but at the same time, it is in the category that they were trying to do for evolution of astronomical instruments. This is one of the examples I'll be coming back to. And there is another kind, the last type of what we can deal with is the instruments for demonstrations. And this is, I think, the divergence point for Europe and Islamic world, because when we talk about demonstrational instruments in Europe, it will be almost completely something else here. Here, I can say these instruments that you see on the left, you are seeing a spherical astrolabe. On the right, you're seeing an astrolabe. They are normally used for observations, and astrolabe can also be used for calculations as well. But individually, these instruments are non-functional, because the Bayezid astrolabe, this one on the right, is made for the Sultan Bayezid II for Ottoman Empire. It doesn't work properly, and it wasn't actually engraved properly because it wasn't the intention to work with. It was quite small to be working with anyway, and the idea is most likely either the Sultan or it could be, and same thing with spherical astrolabe. You can see over there with the shapes are quite symmetrical, and those symmetrical shapes actually prevent it to become more accurate instrument, but just looks much better because it wasn't specifically for using it, but showing what kind of a thing a spherical astrolabe is. So demonstrational instruments in the Islamic world, specifically after 16th century, is just regular instruments not used for any kind of calculations or observations. When we come up with evolution of instruments, we have to go back to the necessity part and curiosity, and because this needs to go together. You have to be curious about to make it better and make it much perfect, and at the same time you need to have the necessities in order to help you come up with these ideas. And what we see specifically in astrolabes and astrolabe quadrants, we see many versions of those instruments, especially in astrolabes, which has so much room to improvement, so much room for changes. And once you have the need for astrolabes because of your scientific works or religious requirements, you can come up with so many versions. We have today more than 300 extant astrolabes from Islamic world, and this should tell us that there are much more than 300, of course. So they had the trial and error periods every time they were making one, and they started to have, with the developments of mathematical knowledge, they started to understand, okay, we can do better, so we can actually create a different kind of markings on it, so we can actually calculate these as well. And they started to advance it a little bit specifically from the 13th century, which the quadrants becoming more effective and more useful, specifically in the Mamluk region from Egypt to Syria, and then the Ottomans in Turkey, Ottoman Turkey, of course. And these instruments had the chance to expand and change a little bit, perhaps more than the others, specifically for the in comparison to observational instruments in observatories, because observational instruments, because they are made large, they are very expensive, and they only made 4 observatories. If you don't have many observatories, you don't have the chance to be able to experiment on them too much. So what you do is actually in every 100 years or so, you come up with a very large observatory in some part of the Islamic world. So trial and error period doesn't go well with those large instruments, so you don't actually have much more quality check periods. And this will be a good example of explaining how astrolabes become from what to where. And on the left, you can see one of the earliest extant astrolabes made by Nastulus. And you can see it's still good, of course, but it's so crude drawings. As an expert, you can start actually seeing so many problems on it. But when you look at the right, in the beginning of the 17th century, you start seeing extraordinary instrumentation. Not just scientifically accurate, much more accurate, and it has more markings on them to calculate much more different things or measure different things, and artistically far more beautiful and worked on a lot with elegance. And this is the change period. Of course, we don't have enough time to be able to explain every detail, but I wanted to give you some idea about how evolution changed the astrolabes or the other scientific instruments. And while this was happening in Islamic world, we see a similarity, a little bit late start, but still the similarities in Europe as well. And we can only say there are so many research to be done to explain the transmissional knowledge between Islamic world and Europe, and back from Europe to Islamic world. But as far as we're concerned, we have three major points of contact, and I should start with Constantinople. And in Constantinople, the Byzantine Empire had natural neighboring with the Islamic world, and they had the natural connections to it because they were also fighting sometimes, but they were also having cultural interactions, economical interactions, and it would help them to understand each other much better. So they were translating some books from Islamic world. They were actually having much more intimate connections with the Anatolian or the Middle Eastern world, but in the Islamic world, of course. But it's so much to be done as research to explain how vast the transmission of knowledge was then through the Constantinople. But it was an important part, and for instrumentation, we don't see too much about it. In the Sicily and Rome connection, it could be again need to be researched a little bit more better. Why Sicily? Because Sicily was in the Muslims' hand around until 12th, 13th centuries, and then even the rulers were Christian. Muslims lived there until 15th century. So they had much better connections to Rome and the rest of the Europe, of course, throughout from 14th to 15th centuries. So that was another connection. But again, this was not the main connector. The most important one that we have to deal with, which has been studied much more than the other ones, is Al-Andalus and the Maghrib, today's Morocco and Muslim Spain. And this was the place of origin for almost many of the instruments or the astronomical ideas as well. And one of the treatises written by Ibn Safar, who was an instrument maker as well, which has more than 3 survived instruments, if I'm not mistaken. And it was the first book to translate to Latin about the use of astrolabes. So this is in the 11th century, and when we see 12th century, we see the first encounter of armillary spheres in Spain with the Muslims and Europeans, exchange of information, of course, coming up. But the main connections, what we can talk about, is coming with specific person, and that person's works is Alfonso, the King Alfonso X of Castile in the 13th century. He, now we have to go back to curiosity and necessities. He was so much curious about Islamic science at the time, science in the Islamic world, science in the Al-Andalus, and he wanted to be able to comprehend all the information he can get from medicine to mathematics to astronomical instruments. He wanted everything to be translated to Castilian, and he ordered his astronomers to do that. And he wanted to see a book explaining how to use instruments. So many treatises were translated into Castilian. But here now we are coming up with the originality part here, because when they translated the treatises, they start realizing all of those treatises are about the use of the instruments, and there is no single one they can come up with about the construction of some of the instruments. Yes, for astrolabe, yes, but for armillary spheres, they didn't have. For spherical astrolabes, they didn't have an Arabic treatise on their hands to translate. So what they did is writing their own treatises to be able to explain. While they are doing that, they actually come up with images to explain much better. And this is one of the images of the armillary sphere, and I'll show you the other ones very descriptive, beautiful, and explanatory with explanatory texts. They combined a book with 200 folios, and this was the very first completely. It is complete in itself, and a book of instrumentation. And this was the beginning of a new era in Europe. And Europeans are now making their own instruments. They are actually emerging with new ideas about craftsmanship, and they have their own artistical ideas. So over time, it'll be a divergence. But divergence doesn't come just because of the information coming up to Europe, and Europe is a different country, but also because of the necessities and curiosities are different as well. When we see that the curiosity and overthrows again the necessities a little bit in comparison to the Muslim world, we started to see more of some of the instruments and less of some of the instruments in comparison to Islam. Because most likely, for example, the astrolabes and quadrants, specifically quadrants, are in comparison to other instruments are very few as opposed to the large collections of Islamic world. This is most likely because of the timekeeping was not too essential, specifically for in public scale. They wanted to have a different understanding. They had a different curiosity, and that curiosity led to very shiny, very large, very beautiful instrumentation for demonstrations, not for use of observations or calculations, but demonstrations. And celestial globes and armillary spheres, one you can see here, a magnificent armillary sphere by Antonio Santucci. And when they started seeing that, they started to comprehend the universe as a demonstrational tool. They use these kind of instruments. Of course, this is more of like 16th and 17th century, but and we also have observatory instruments in Europe. I'm not saying they never had that, but you start seeing necessities continue, follow through some things, but curiosity takes to another level in Europe with artistic inclinations change as well. So that is the point, I think. But before ending this session, I would like to be able to say about the translational knowledge and how it works a little bit more. And what we see in the history of science, once you start making something, when you start creating a knowledge, it doesn't die, almost never dies. And someone can come up with other ideas using your knowledge. And as long as, even though they actually hide the books somewhere, like it happened in the Byzantine region, when in Anatolia, when they were not using Greek books, they were actually putting on the boxes. But then Muslims found them and tried to take advantage of this, and then the same thing happened quite closely in Europe, the Islamic world. Whatever knowledge you try to come up with, it actually travels far more faster. Even in 1,000 years ago, we say today the globalization happens now, but well, not just now. It was global then, and even though maybe a couple of years, time lapse, it happened, but still the knowledge was traveling around the world, specifically between Europe and the Islamic world. And what's important here is, once you have that knowledge, what is your curiosity lies and what is your necessity lies changes the course of the development of scientific instruments or the scientific ideas in any way. So, but there is wherever there is curiosity, there is always some sort of a necessity, because it is a loop. First you become curious, and then that curiosity makes your mind start feeling more necessary things. And once you started to work on those necessities, you started to become more curious to go a little bit further, because we as humans do not content with things easily, and it is helpful with the scientific development. And once you have those kind of a transmissional knowledge as well, it becomes much more culturally diverse, and you can come up with more ideas throughout the experiences of the history. that's what I want to say. Thank you very much for listening, I think. And we have good time, yes.
Thank you very much, Taha, for this truly enlightening presentation where you covered so much ground, not just chronologically, but also, of course, in terms of area and countries, parts of the world you touched upon. And questions have been coming into the chat. The first of those does actually question your point of curiosity and necessity. Stephen asks whether there is another motivation which should also be considered, and that is meaning. So we usually think of meaning with the term astrology. The sky as a theater of science importance, where the personal and communal significance of the heavens is what matters. Wouldn't that have been a bigger issue for most people? How do you feel about that?
Well, I think if I could come up with more explanations of the curiosity, I think I would put under the category of curiosity as well, I think, with a meaning. But that is true. I mean, what I try to explain is not actually cover everything, and I apologize from everyone that because this is a short introduction of things, I had to go to some generalization, which I usually hate doing. But there is nothing else I can do. If it had 14 weeks of lectures, yes, I could explain more. But I think, there are so many factors that you have to put in, and meaning, yes, it is. But from Islamic world, and as a person who worked less on astrology, I am not qualified to be able to say it properly, to say, yes, that is a connection to, Apologies if I couldn't answer that.
Thank you very much. I'm sure there could be a follow-up by later or by email, maybe. Really interesting question, and your categorization there, I'm sure, has many people in the audience think, or got them to think about what is it really, what the drivers are. We have a very, very different question on a completely different topic from Flevolot. That is about the decoration. In the 13th century, why did the taste for astrolabe decoration change so much? We have looked, of course, at a number of examples, but you I'm sure, will be able to comment on that.
Yes, let me just show you. I could have turned this off, actually. Well, I think what we can show and what it is, let me see, apologies, let me go over there before answering, because it is quite shiny. And going very slow. Yes, that one on the silver inlay astrolabe on the left is from 13th century Egypt. I think depend on the instruments and depend on why they wanted to make them changed a lot, because in the beginning they were only using for literally calculating the time, but over time astrolabes are quite significant instruments, just showing that scientific development of the time. So even rich people or the sultans or people who has high offices wanted to have a piece of this magnificent artistic things, not just for observation, but at the same time for those things. And sometimes you start seeing, especially this happens in the 16th, 17th century Iran with the Safavid dynasty. We have so beautifully made instruments, but they were never used. You can see they are still in pristine condition. They were not made for usage, and they were trying to just put it over there. I think just looking at it, which I do usually, I look at over there and see my own replicas. Even my replicas looks good to me, and I imagine having that kind of a wonderful piece in your hand is important. So maybe it's not the answer of the question, but it became more popular, and when it's more popular, they always have a better version and a working version. So what we see usually, which survives today, is usually the one that they didn't actually use it for regular timelines. So I think because of that.
Thank you. We have a question from Anahita that consists of two parts. The first part is ask whether you could say a little bit more about the development of instruments at Maratha University, Observatory rather, in the 13th century. And the second part of the question is whether the astronomical instruments also became part of the practice of gift giving.
Well, for the first part, I can say many things. I think the Maratha Observatory in the 13th century was the very first observatory to be able to tell we need large instruments and we need systematic observations for a very long period. And then we need to have great mathematicians to calculate those data for long-term astronomical tables to be able to use it and comprehend the problems and solve the problems of the Ptolemaic ideas. The Earth is at the center and everything is revolved around it, which creates so many problems. And Maratha Observatory, led by Nasruddin al-Tusi, who was one of the pioneers in the science in the Islamic world, in astronomy in the Islamic world, with coming up with many different ideas. And I think it requires a special session to explain the developments and importance of Maratha. But yes, it is quite important. That was the question. I explained a little bit of Maratha. Silke?
Yes, please.
Was that question? Explain a little bit about the Maratha, I think.
The development of instruments at Maratha University Observatory in the 13th century.
And they showed, well, they were not just pioneers, but they were also, there was a beginning point for much better instruments in Samarkand, in the observatory in Tabriz as well. And when they see Maratha and when they see the success of Maratha, they wanted to say, okay, we want to do a little bit better than this and perhaps longer than Maratha. So it was a turning point for the large observatories in the Islamic world. And the second question, gift giving, I am unfamiliar with it. I'm sorry, on the gift giving, we know some of the instruments on the back, they have inscriptions explaining this was made by this and for this person. But apologies for that, but I did not actually research yet about how they were used as gift giving, or was it really something in the records to work with? Because instruments I worked on did not just show for this person, from this person kind of inscription yet, so I can't answer that, unfortunately.
Thank you.
Okay, I think about this.
It's always so good to have things to think about when it gives a presentation. Certainly very inspiring. We have a question which goes back to the earlier question about the categorization or the classification. Anna Carolina asks whether there's any research or any publication you can point to about this classification, because other researchers, for example, Jim Bennett, have put forward different classifications.
I'm afraid not. This is my classification. So I am trying to come up with two different things. One, for when we say medieval, it doesn't fit well with the Islamic world. So I'm not using medieval as I'm trying to use less and less with the medieval idea, because aging, the periodization in Islamic world is quite different, specifically about the time, about the scientific development. So I try to come up with a new periodization of the Islamic world. And when I am working on this, this categorization or classification fitted well with my research, but I haven't actually written anything or published anything. I did write many things, but did not publish yet. So unfortunately, I can't actually say, because there are so few people working on instruments in the Islamic world. David King has different classification, of course, and of course there will be so many different versions, and in the end, perhaps I might actually come up with a different idea. But I am open to suggestions and counter arguments, of course. Yes.
I'm sure everybody will be looking forward to seeing the publication, and will keep some space for the book on their shelves. So there's a very different question which has just come in from Isabel. Instruments which were developed in Europe in the 16th and 17th century, particularly for navigation, do you think they are the result of transmission of knowledge between Europe and the Islamic world? Is there any relation between the context in which they were developed?
I think so, but it is far-fetched idea because, well, Europe was already developing their own mathematical problems and geometrical ideas about how to make instruments already in the 13th century and 14th century. So when we come up to 16th century, they had already mastered what they learned from Islamic world, and they were actually exceeding from that. And there is a problem with this. When I try to give the 3 points of contact with the Constantinople and Rome, is actually still in the shades. And the main problem with this transmission, most of the things they transmitted in Europe from the Islamic world is coming from the Western Islamic world, but not from the Eastern world. So when they learn about things from Muslims, they were assuming that was the only thing coming up from Islamic world. But if they could actually have much better connections to East, which had far more superior in knowledge comparing to Western Islamic world in Andalus, because in Samarkand's observatories, instruments, Samarkand's ideas in astronomy were far more developed comparing to in the Western world, Western Islamic world. They could have actually had more connections, and it would have been continuing the influencing from the influence was transmission of knowledge was continuing from East to West, from Islamic world to Europe. But if I'm talking about a 16th century instrument in Europe, I think slightly from Islamic influences, but they actually have their own ideas, specifically on mechanical clocks, for example. They already had before Muslims, so they had their own merit as well in this matter.
Mm-hmm. Thank you very much. I'll just ruthlessly take the prerogative of the chair here and ask a question myself, if I may. I'm fascinated always by the question, what does this mean for, let's say, the ordinary person, day-to-day life? How were people on the street affected by the instruments? How were they involved in the discussion? Were they close to them? Did they see them? Or was that a very small group of people?
Well, before perhaps 10 years ago, if you were trying to answer the question, we would always talk about astronomical instruments, and astronomical ideas were discussed only by astronomers or in closed circuits. But more and more studies now coming up, and we start seeing people from different backgrounds learning astronomy, learning astronomical instruments, learning astrology, just to learn. It's not just for employing them in their work as an astronomer or a timekeeper, but they were just learning as part of their intellectual life, perhaps. And in madrasas, the schools, in the equivalence of high schools today, they were already teaching astronomy, but they didn't have to use it all the time. But they can be employing the information perhaps a little bit. But I think we have, from my understanding, from the studies I'm reading, not studying myself, but reading, I can see it was inside the Muslim life. In comparison, they were, let's say, in Ottoman Empire, they had the house of timekeepers, and they would prepare prayer tables, and they would put up on the wall, and people would come over there and just check their times for prayer for the month, for example. Mm-hmm. So they could do that. So it was always some relation, and it wasn't just a secluded sect doing things without any kind of information from the public, I think.
Fascinating. We've got a very different question here from Martin, who asks about the practicalities, really. Did the instrument makers work as individuals or as families, or were there kind of guild-like organizations sourcing materials and parts from different locations? Can you tell us something about that?
Yes, and I think the question is actually has already answered some of it, because when you talk about guilds or families, it is true. And there are individuals working on instruments, and there are two types of people working on instruments. One, an astronomer comes to a craftsman and says, you need to make these instruments, and they make it for you using your descriptions or writings or whatever it is. But sometimes an instrument maker would become an astronomer, or astronomer would become instrument maker himself. So Ibn Shatir, for example, makes his own instruments. Mizzi, one of the most prolific instrument maker from the 14th century, was making instruments, but he was also a timekeeper. So we have these individuals throughout the history, but at the same time, we read specific notes from different parts of Islamic world explaining, oh, I bought this this instrument from Harran, or I have seen celestial globes made in Harran, a city in southeast Turkey today. And you start understanding there is a workshop over there, or there are some workshops over there, and they were glorified about how to make a better instrument than the rest of the region. So people go over there to do that. And much more documented version of a family working on this is Allahdad family in India today, and in the Babur Shah's empire, the Mughal empire. In the beginning of the 16th century, throughout the 16th century, actually, they were for 3 generations of family members, uncles and their nephews, working on making instruments, and they made 134 astrolabes, I think, if I'm not mistaken, close to that number, celestial globes, and they had their own style of workshop. They had their own style of making instruments, and using different kind of methodology than the rest of the world. So you can spot it quite easily. Oh yeah, this is from Allahdad family's workshop. You can even say that when you look at their trademarks, I think so.
Thank you. Marina takes us back to a very different question, and that is ancient text. For example, John Philoponus, and the influence these classical texts may have had on Islamic instruments from the Islamic world. Would you say a little bit about that, please?
There are definite influences, because very early age in the Islamic world, before the end of the 8th century, we have a person called Al-Fazari. And Ibn Nedim, one of our historians from 10th century, he records him as one of the astrolabe makers. So now, quite interestingly, we don't even have books about astrolabes yet. How can he come up with an astrolabe and make an astrolabe using what? So we have some blanks to be able to we need to fill, and I'm quite sure the main idea is coming from Greek anyway. So they were actually using those instruments. They were actually, the manuscripts, and translating perhaps crudely, because the translation movement achieved high quality in the 9th century, for example. And they even begin using perhaps some of the instruments, like sundials coming from Greek, of course. You can see sundials used by Muslims before even the translation movement happened in the 8th century. So there is definitely connection, but pinpointing them is quite hard. If someone wants to work, I try to find the resources as much as possible and give it to that person. That person can come up with a PhD study, perhaps. Who knows?
Well, thank you so much, Taha. We have to wrap it up here. Thanks to everybody in the audience for being with us today and for your really, really interesting questions. We could continue this much, much longer, and I'm sure would have a wonderful time doing so. we'll all be looking at the instruments behind you there, Taha, and of course we hope that sometime in the not too distant future we will be able to handle those back in Oxford. But for now, I just wanted to thank everybody. Also, in case you want to support us with the program we're doing, with our events, with our exhibitions, please feel free to do so, and information on how to do this will be posted in a moment. And I would also like to invite you to our next event on the 12th of November, the second event in this series. Professor Julia Bray, on the 12th of November on Arabic books and astronomy in 17th century Oxford. And you and Julia are working together, Taha, aren't you? Yeah. So it would be lovely to have Julia with us next time. So, but for now, thank you all very much for joining us, and goodbye.
Thank you for having me. Thank you very much.